2 more lessons and the trimester is over. So let's attack. 12.3, trig functions of general angles. Same thing as 12.3 day 1, but we're going to pour on some negatives and just have you consider what happens in different quadrants. Here's your memory tool. So if you draw some random triangle over here, you're going to have a positive, 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 and if this is your reference angle, if you did so, ta, toa, there's no way you could get negatives because everything is positive. And so we would say in quadrant 1, sine and cosine are positive, cosine and secant, positive, tangent and cotangent, positive. Everything's positive in quadrant 1. However, if we drew a random triangle over here, my adjacent side would be negative, my opposite side would be positive, my hypotenuse is always positive, don't forget that. So if this is my adjacent side, and this is my opposite side, and this is my hypotenuse, a whole bunch happens. Now, rather than have you guys memorize all of these and have to figure it out every single time, there's a little trick. All students take calc. Now, that's not a true sentence, but it helps us memorize something. All things are positive. Only sine is positive in the second quadrant. Now you could prove it, because if this is your reference angle, opposite is positive, hypotenuse is positive. So positive over positive is positive. But if sine is positive, then so is the reciprocal cosecant. So in quadrant 2, sine and cosecant are also positive. But if sine and cosecant are the only thing positive, that means cosine and secant would be negative. Could prove it. Adjacent is negative over hypotenuse. See that? Cosine is defined by adjacent over hypotenuse. Negative over a positive. Tangent and cotangent would be opposite over adjacent. You can see a positive over a negative, so that would also be negative. Now, take is representing tangent. Tangent is the only thing positive in the third quadrant. But if tangent's positive, then so is cotangent. So that would be positive. And if you think about it, my adjacent's negative, but my opposite is also considered to be negative. This is down. So opposite over adjacent would be a negative over a negative, which would give us a positive. So if tangent and cotangent are the only things positive, then sine and cosine are negative. That means cosecant and secant are negative. And then calc stands for cosine is positive. But if cosine's positive, then the reciprocal function secant is also positive. So there's positive, and these would be negatives. There's a lot going on here, but as soon as you memorize all students take calc, it kind of takes care of it for you. All right, now we're going to put this into practice. Find the trig values, that means sine, cosine, tangent, and then figure out what the reciprocals are. First thing we got to do is plot this point though. Now I'm going to make my units huge so that my triangle's huge. That's -1 and then up 1. If that's the point they're talking about, they're saying your spinner stops right here. Notice I just drew a triangle. Where's the reference angle? It's always here between the hypotenuse and the x-axis. All right, well, this is just a fancy way of giving you guys a 45, 45, 90. And so if this is x and this is x, go into your geometry rules, this is x square root of 2, or just 1 times the square root of 2, which is the square root of 2. Now, if you multiply this by the square root of 2, don't be tempted to say it's negative, because your hypotenuse is always positive. Remember that. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent opposite over adjacent. So what's the opposite side? 1. What's hypotenuse? Square root of 2. Now I'm going to put a box around that and talk about that in a minute. But I got to get the square root of 2 out of there. So I get the square root of 2 over 2. What's cosine? Well, it's adjacent over hypotenuse. And again, I'm going to put a box around that. We'll talk about that in a minute, but I'm going to get the square root of 2 out of there. So I get the negative square root of 2 over 2. Tangent is opposite over adjacent, which would just be negative 1. 1 over negative 1 would just be negative 1. Now we're going to flip these things. So if I flip this, sorry about the mess, I'd be finding cosecant. And I'm not going to flip this. I'm going to go to what I box, because this is so easy to flip. So it'd just be a square root of 2 over 1. I'm going to do the same thing for cosine. This is just, the reciprocal of cosine is secant. And rather than flipping this and having a whole bunch of work to do, I'm just going to flip this, which would be negative square root of 2. And of course, cotangent, pretty easy. If I flip this, I'm just going to get negative 1. So that's the hard part of this section. The rest of this is just having you do a little exercise, finding the reference angle after you spin it. And you guys have done these before. So we just got a spinner, 136 degrees, which means up. Keep track of this stuff, 90 plus, and again, just be close, 46 degrees, and then you stop. Question, is this your reference angle that they're asking for? No, because it's got to be sandwiched between your spinner and your x-axis. So they're asking you to figure out what this is. Now, there are a couple ways you could do it. You could go 180 minus 136 and just get 44. Or you could ask yourself, all right, if this is 90, which it is, I could go 90 minus 46, which is just 44. So either way, you're going to get 44 degrees for your little reference angle here. All right, how about negative 128? Well, that means we got to go down. Keep track of your 90s. There's 90. How much farther do I need to go? Exactly 38. Is this my reference angle? No, no, no. This is. So I'm just going to go 90 minus 38, which would give me 52 degrees, and that would be my reference angle. Now they're going to throw some decimals at us and see if we can hang. There's my spinner. I got to go down. Now notice I went 180. How much farther do I need to go? If you need your calculator, use it. I need to keep going 60.8 degrees. Question is this my reference angle? Yes, because it's sandwiched between my x-axis and my spinner. So that's it. That's my answer.